How's it going, everyone? Welcome. Elier Gonzalez here. Today is about front-end system design. Why this is important, especially if you're going to be a UI specialist, you need to understand is the fundamental of how all of these pieces combines and works together as a way to now build these scalable web applications. That, of course, the point of this is not only be able to design that in the most efficient, easy way to maintain, but also when it comes to actually maintain this application, this front-end system, there is also another course that is made by Steve Kinney, again, another front-end instructor, that actually give us is how we're going to actually maintain these kind of applications in for this enterprise with when they have these large code bases in a huge amount of contributors, right? Scattered across different teams. So because this focuses on how can we now design these things, all right? And again, any design is not perfect, but the idea here is to actually make and develop a sense of what are the things that we need to have in mind, in place, okay? So we can now move forward to that. So especially if you're now building as a front-end applications, first you need to know that there are certain responsibilities that you are going to handle, right? At least in 2024. So first is the way of how you can communicate your API, this API communications, as well as how you're gonna manage your states, data management, how you're gonna store and then access to that data. Also, the way of how you're going to handle is this user interactions and what are the common patterns to go with to solve specific problems using, for example, the observer API that it has now the intersection, the mutation, and the resize, right? And each one of those cases falls into a particular business use case, right? So the intersection observer is most of the time for lazy loading or virtualizations, or when you want to now measure some metrics for analytics, okay? As the user scroll in, you want to actually measure that. The mutation is more like when you want to detect change on HTML elements, whether it's HTML elements or attributes or the text content or any of it is a child component. Useful, for example, when you want to implement a text-rich editor or any drawing tool. And for resize API, so you know you're going to have is similar like the previous one. When you have is the intersection and the mutation, so each one of them create now a queue of how it's going to append all of this particular task as a way to not consume it, or as a way to not use the existing queues, for example, like timers or promise, okay? So again, this is something that is very specific for this particular case to handle this common use case. And in the case of resize, is also have now this observer or this particular queue to actually now detect when a change on the viewport happen or in an element, okay? And then run a callback, but do that in the most efficient way possible. So this is something that you're gonna use especially for graphing tools like the trading applications. This is one of the most common use case. For example, graphic or charting tools, as well as for responsive design, okay? But once we look at that, all right, then another area of responsibility is the asset management. So the TLDR of all of this, right, is that here we're going to see now, sorry, here we're going to explore now is this particular WebSocket, okay? So because first we look at what are the fundamentals of the browser, and that is how now the browser treat HTML, and then now how all of these particular elements participate in something known as the formatting context. So anytime you create a block, a box size or a box model with the type of block or inline or flex or grid, you are actually creating is effectively a formatting context, which indicates how all of these elements are going to behave, which is great. It also gives you now scalability and predictability, which is something that you want. And when it comes to actually now tell the browser to use the GPU instead of the CPU, because CPU is something that is used, for example, to calculate is this logic and arithmetic operations. One of those operations is the reflow, which the reflow is now the segment in which now we let me see if I can put it here. That's right. So now the reflow here is one of the face of the browser. Okay, as the browser is taking all of this HTML, CSS, and JavaScript and transforming into a pixels on the screen, and as you can see, building a browser is something that is not trivial, because now you have things like Firefox, where Firefox, let me see if I have this here. No, anyway, that'll be interesting. Yeah, for example, Firefox line of code, right? Actually have more than 31 million and a half line of code. As you can see, so it's building a but it's mainly is written in C and JavaScript, C++ and JavaScript. So as you can see, is something that is not trivial. Holy moly, it's actually representing almost a fourth of the entire code base. Jesus, C++ and JavaScript actually represent is a half of the code base. Anyway, there's some initial movement through Rust. Interested? But in any case, code lines. Actually, they are the oh Jesus. They're quite the same. They call the line of code. In any case, this is just as a way to see that running and building a browser is something that is not trivial. And that's why we have now this particular phase of the reflow, which is going to calculate is now the layout. In other words, is the portion of how now the browser say, hey, now that I receive all the information that I need from how it's going to look like, or for the structure and the style, which is from the DOM and the CSS, you combine them into a render tree. Now let me actually calculate its geometry and the position of this element. And most of the time it's used now the CPU for that. So how do you actually make sure that I didn't lose my mind? Well, because when you now changing is the mutation, for example here, when you are changing now the position or the geometry of these elements by using its width and height and that kind of thing. For example, here margin top and margin right. We are now able. Let me see if I can actually open up here the. Let me see if I can see that. To debug to the performance here. Performance start recording. Yep. Oh no, but this is for Firefox. Oh, no. Exactly, start recording. And then cancel recording. Oh, okay. And then capture recording. Okay. So as you can see here, is now using a lot of the CPU as expected. But now it's because it's using the render, right? It's because it's using is the render here. Not sure, is this one? But now, if we switch now to the switch to paint composite, okay, switch to paint and composite. Okay, we were now on the switch and compose, which is actually calling is the render here. Call tree, stack tree, market chart. It's now the rendering, the compositor. It's actually using CPU here, but not that much. Okay, but now when you start to recording is switch to. Okay, let me see how this actually thing works. All right, let's go to record this. All right, so switch to layout, paint, composite, which means that this is the optimized performance. Okay, this is the optimized pipeline. Let me actually start recording that. Okay, so now it's actually using the GPU instead of a GPU, and we will capture the recording. That's right. It's supposed to use exactly is now the GPU, not the CPU. As you can see, is then on average it's not using that much. Okay, but now when we switch that to the not optimized version, okay, which is using as a CPU, is now changing the position of the position and the position here of this element, but without the CSS class that allows to access through that to the GPU layer. Let's gonna see how this behaves right now. So as you can see here is now using this one. All right, there's also something weird to read about this. There's also something weird to read about this, because I don't know how it's actually showing that. So let's go. Okay, let's go with. Let's go with. Let's go with Chrome, bro. So let's go with Chrome. Yeah, let's go with Chrome. Okay, let's go with Chrome. Yep, let's go with Chrome. Okay, this is now the layers that I created. So if we are profiling this, okay, we see that we actually are not using a CPU. However, when we now switch to the other one, we see that we are now actually using the CPU, right? To actually is exactly now it's triggering is the layout phase every bunch of milliseconds here. The point of this, okay, is that now the whole idea of this is to see how you can now is talk to the browser to use now the GPU, okay, instead of the CPU by using is this CSS specific class like transform that allows to do that. So far so good. You know, that's something interesting. That's what we want at the end of the day. And to do that, well, we need to understand what is happening behind the scenes when we use this. And also is that how can we now starting to build and create all of this particularly simple interface that will make our rendering of application much more faster, right? So that's what we look at, for example, understanding what are the global objects in JavaScript, and also the DOM capability that we can have access to. So for example, the DOM class hierarchy, which is the node, everything is started from the nodes, and then you have now the text node that is come from the node, also the element, as well as the specific type of element, which can be HTML, math, SVG, and also is this document HTML element. And what are the most common operations that we can use, especially to query data, and how this data is represented in a tree-like structure. And by using this get element ID and class get element by class name or tag name or query selectors or query selector all, what is the trade-off? What is the performance best practice to do that? The TLDR is that use your ID as a way to now get a starting point of your element, the starting point portion of your element, to actually then use now query selector to get the elements that you want for that. And how now this kind of operations, some of them are worse or better, but the whole point of this is to use the append child. And that is something that behind the scenes React is doing for you. So we also look at how we can use the document fragment as a way to make sense of all of this and all of this web pattern. But I want you to stick with me here, is that the responsibility as the front-end engineer, or this UI especially, is that API communication, something that we're going to talk about in today's video, okay? API communications, data or state management, which is something that we already saw that, okay, briefly. Data management, you are handling UI complex patterns, something that we already saw, and the asset management, something that we're going to see later on. And how when we need to actually is handle our state of the application, okay? The rule of thumb of this is ask yourself, what is the scale of the data that we're going to store, okay? And then from there, ask yourself, exactly. No, this is virtualization. Actually, we didn't want to actually dedicate too much time. So, but when you now do this application state design, it's like how big is this data that we're gonna store here, okay? Because most of the time this data can be or configurations, which can be the user configuration, templates, locals, font size, that kind of thing, or it can be element states, UI element states, or the server data, or the data that is relevant for our applications to manage. Okay, so the TLDR of all of this is that when you now is to store this kind of application or manage the state, when you're going to design this application state, it's important to ask yourself a couple questions. what is the data that we want to store, and what are the principles that we want to make or to want to maintain in this design systems. In this, what are the principles that we want to keep in this design system? And that is, we want is to uh, improve the read cost as well as the access cost. Okay, that's when the thing is starting to make a lot of sense here to understand is this principle, if this design goals of this is like, hey, I want to minimize is the read cost, the access, I want to minimize is the access cost, the search cost if you have the data, as well as the size of this data, the memory usage. I'm gonna make a quick pause here before we move on. Ooh, getting hot. Oh, yeah, it is. Here we are. Here we are. Okay. Okay. Whoop. Way much better. Yeah, actually it is. Change here. Stop. Stop reading that. Stop reading that. Wait a single moment. As you can see, And someone that actually do a lot of exercise. Yeah. I'm a gym rat. Wait, what? And there we go. Give me a second. I'll be back. I'll be back. I'll be there. I'll be there. Best way you can lose weight. This is the best way you can lose weight, bro. Oh, yeah, it is. Ooh, you want to lose weight? Stop eating, bitch. Stop freaking eating. Maduro's diet. Socialism diet. You wanna stop being fat? Well, stop eating. Simple like that. It's on fire. No, it's not on fire. It's not on fire. Just kidding. Oh, that's good. put it here. Okay. All right. All right. Ooh. Oh my God. All right. Oh, let me actually do this, in fact, so you can hear me much more better. So you can hear me with a lot of less noise. All right. Well, I think you can hear me a little bit better, so I don't need to actually scream. Okay, so we are here. It's because, especially when you are now, we talk about is the general principles, and why is this? Especially if you're going to design something, okay? I'm gonna make a quick example here. If you're going to design your life, okay, you want this to actually start for something, and you need to actually have a goal, an end goal to do all of these kind of things, right? It's like, hey, if I want to design if I want to do this life system design, uh, I want to actually is make my health as a top priority, also earn some amount of money, and share with others, right? You can quickly summarize this. So this is now the goals of it. This is now what we need to actually is work towards to. The same here is for this application state design. Is that this is are the things that we want us to now work towards to, which is how we're going to store our data. How can we minimize is the access of our data, as well as the search if we want to implement any search operations. And the memory use as well. So the TLDR of this is that first understand what is the scale that you're going to store in your application. All right, start from there, and then model the data that you're going to store. Okay, which is something that the mention is here, right? So model the data that you want to store, which is always start with how you structure your data. Model the data, how you're going to organize your data as a way to store them here. And when you need to minimize the cost, well, normalize the data, which is a concept from the database engineering is known as the normalization. So apply some of these normalizations. So there are right now is 7 forms of normalizations. Most of the time we just apply up to the second or the third. And the first is, hey, let's going to now make all of the keys in an entity unique. Okay, so flat that object to only one. Okay, to only one level. And the other is that non-primary key must depend on the key of that entity, which is, hey, you're gonna now put all of these tables or objects in their characteristic to that, right? All of this, so this object is representing is this data, okay? And that has this data associated to that. And also, this is the second form. The third form say, hey, no. The non-primary key must only depend on the primary key data. So it means that you're going to actually is create a little bit more of this objects or this space in memory that they're going to have all of this reference. So this is now how you can is improve. So yeah, this is now how you can improve is the access time. All right, and when it comes to if you need to implement some searching operations, you can use is now index to do that, or inverted index to do that, and then you can store that not on JavaScript but on IndexedDB or any other of those storage, especially IndexedDB. as your key. And then data that is not needed on the main memory, okay? Well, let's go to now offloading that to any other data. So a good example of this is if you need your keys, you want to have them close to you, right? In some close pocket to you. So you don't want your keys to be is at your bedroom's drawer, right? This one is that here, close to you, similar to your cell phone. You know, you want your cell phone is on the bed while you are on the restaurant. It's like, oh, Jesus, how now I get it? How do I get in here right now? You know, so that's the whole point of this is of how you're going to now work with this memory, and which are the memory that you want to now is using in the main memory, and what are the others that you want to delegate that. This is also known as sharding, okay? And that's a very interesting concept, especially for database engineers or for people that actually are in that particular field. Ooh, oh, awesome. Mm-hmm. Mm-hmm. Mm. 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 Sorry. Oh, interesting. All right. So then now we talk about the network connectivity. Okay. How we're gonna now handle is the API communications. So it means that we need to understand is that how now a request, how do we navigate, how can we describing the navigation, okay? So we want to do that particular thing is like, hey, the way we do that is by sending now is our request. So when the user type a request on the URL in the Google in the browser, now that is sent over through the computer through this thing known as the OC model, which is the way of how now different computer systems can communicate or can exchange message. How can they interconnect each other's? This is how they interconnect each other, and that is star for all of these particular stacks here, right? So you have now is the application layer, which is the connection between the user and the applications with the network service provided by the OS. Then you have the presentation which say, hey, what is the format that this data is going to be sent? And this layer also is responsible for the encryption, right? The presentation of this data. What is the format? What is the usable format of this data? And if we're going to encrypt that, then the system takes care now of how we gonna, for which port we are going to now send this data, right? Is controlling the ports and the system. Okay, it maintains also the connections for that. That's very interesting. Mm. Mm. Mm-hmm. Ooh, okay, well. It maintains also the connections to that. So this particular layer, the system layer, is say, hey, it's going to now is let's go to now is coordinate the connection, all right? So maintains the connection, maintain this particular door open, maintain the connections, and controlling is the port and the season. And then you have now the transport layer. We say, hey, all right, but how are we going to now send this data, or how are we going to transmit this data? What is the protocol we're going to use as a way to transmit this data? And this can be TCP or UDP. It is, hey, the way how we're going to transmit this data from all these previous layers, it is connection based, or are you just going to send data and I don't care if the receiver is there or not? It is UDP, right? And then you're gonna know, you need to know is what is the physical path that this data needs to go with. That's interesting. This is the internet layer. What are the physical devices across the network it needs to go through until it reaches to the destination for this package? And the next is, okay, so this package, all right, how am I going to send in the most effective way possible? How this package, what is the format of this package that I'm gonna send? This is known as the data frame. And this layer is now indicates how is this communication between these two close devices. That's very interesting. Very interesting. Very interesting. And then you, last but not least, once you know is that the user wants to actually is access to the server and request some data. In this case, the network layer, or in this case is the Google. All right, and then on this layer 6, it's saying, hey, all right, let me now is see if this is a usable format and make the encryption of this data, and then see how we're going to set up, see how we're going to establish the connections and control the ports and the season of this, right? So you can think of this as the bouncer at the database network or the database endpoint, right? So see how we're going to in this layer is that how we're going to now establish a connections, and how we're going to establish a connection, all right, in controlling the sockets and the seasons here. Who can get access to this particular report and who can't, right? And hey, provide me some sort of credential if I need to verify that. And then we say, okay, so now that we know this data, what is the protocol we're gonna send this? Okay, am I going to send this data? I don't care if anyone is connected, UDP, or I need to someone on the other side is connected before establish the communication. Okay, I need to someone is actually looking at me to see if there is, hey, we are now sync. Okay, and then how this data is going to navigate in the physical world, all right, across all of this device. Once we know that, how this data, what is the package, the format of this data that is going to be sent across all of these devices. And last but not least is the physical layer. So once we were able to describe is one of those phases, okay, now I can is move on to, well, this request fly await, and then now is because it's only containing is this URL, it go to the ISP. The ISP detect that, and they have now their own DNS servers, or they have some sort of third-party vendors that actually have their own DNS servers, where they're going to store all of this records of URLs and IP address. Okay, so they're gonna see, hey, now I received this URL, it matched with this particular URL. This is now the physical address on the internet, right? So now you get that, it's sent back to the browser. The browser can store that IP, and then is when it's going to make the request or send the data to that particular server or computer that is, it can be close or as far as from China here. And by the time you actually reach that, okay, then we need to establish is this TCP connection, because after all we are using is now HTTP, HTTP to communicate that as a way to now use this format, this protocol to actually transfer hypermedia context. Okay, we need to establish first is a TCP connection, because this is a TCP. We need that the other side actually is there. So we establish this TCP connection, all right? And how we do that is by sending is this SYN/SYNAC ACK, all right? So we actually send 3 requests before even actually have to communicate or send the request to the server, right? This particular process is something that is quite slow in HTTP 1 versions, and that's why we have now this HTTP 2 version that is allowing us is to multiplexing capability by allowing to send several resources on an HTTP or by allowing us to send HTTP stream over the same socket. Okay, so it can be HTML, CSS, JavaScript, you know, but there is a capacity here, which is 1 of 1. In HTTP 1.1 version, there is a capacity here, and that is the maximum is 6. That you can establish persistent connections for that. So there are limitations in the design here, usually scalability limitations. Okay, so the more these people actually use this particular tool, the more it needs to scale that, right? Because if you don't use it, it's like, why do I need to do this? And the other is that we are sending is the header. So the header is not compressed. And that's one of the HTTP 2 now say, hey, all right, let's go to actually is improve this, right? So we're going now to provide a more multiplexing capabilities, okay? So we can now actually send up to 100 simultaneous, we can establish 100 simultaneous connections. That is something that is going to be agreed upon is the client and the server. Here in the HTTP 2, that will be something quite interesting to actually test that out. Okay, as a way to say, let me actually ask perplexity here. Is perplexity here? It's like and also to claw here. It's like, hey, how can I test how can I test or generate a code that allow me to understand the difference between HTTP 1.1 and HTTP 2.0 using node.js. Here we go. And you're going to get it. Exactly, including multiplexing, server push, and header compression. Let's get into this. Oh my God, here we French toast God, bro. Oh, holy crap. Chill, bro. What the hell? Mm. All right. Okay, okay. The code. Jesus. Okay, okay. Mm. Mm-hmm. To run this code, you will need to generate SSL certificates. HTTP2 require HTTPS. Interesting. And let's get into this. Let's definitely get into this. So the code demonstrates several key differences between HTTP 1.1 and HTTP 2. One of them is multiplexing. Makes sequential requests one at a time. HTTP 2 allows multiple requests and response in parallel over a single connection. Good, good. Here is our HTTP 1 server and HTTP 2 server. Okay. Case for image, case for screen. Okay. That's one of the reasons why Express actually allows to make that thing much more easy to go with. All right, because we don't need to actually create all of our if or switch case to actually handle, as you can see, all of those different things. So that's interesting. That's good. They both of them are running in different ports. Exactly. Okay. And now it's going to actually run all of them to actually check that. So now here, this is the class client for demonstration. Let's go to now actually run this console.time HTTP1 total. This is the resource, okay, this particular order, and then you want this to actually exactly make some HTTP get to that here. Exactly. Hey, I want you to now do a get request, okay, to this particular server. And by the time we now listen to this on data, which is event listeners, here is like, hey, this object, which is very interesting. You take a look, http.get, okay. I'm not sure, is this, no, in node, exactly, in node, holy moly, there's in version 23, Jesus, you are on fire, or you have nothing to do, I will argue. Now you feel the pressure. The HTTP model here is exactly HTTP2 and HTTPS. We are looking is at the HTTP, that's right, and this is the client request, the agent, and the server, which is the response server, right? Exactly. So this object is created internally by the HTTP server, not by the user. It is passed as a second parameter to the request event, exactly. But in our particular case, we want it to actually is once we get that data as a response, you can have access to all of this as it is, right? You can say, hey, you want to access to the close, the finish, add trailers, or the connection is also deprecated. Now use stream duplex, all right? See response.socket, .end, interesting. Response.finish, floss header, get header names, get headers, has headers, remove headers, response.request object, so you can see what is the request, who made this request, send date, set headers, okay, so set headers on this response, set timeout, okay, you can also use timers here, okay, response.socket, status code, status message, string content length, encore, writable ended, writable finish, write, Write early hint. Write head. Interesting. HTTP incoming message. Okay, but no, this is what we can, then you can say is write processing. Sends an HTTP one or two processing message to the client, indicating that the request body should be sent. But this is one of the things that we can look at our response. Okay, so our response not only can say, hey, oh, this is interesting because this is coming from HTTP ongoing stream. Exactly. This is HTTP server response. Okay. That this now HTTP server response, which is a class that have this event and this particular property and methods. This object is created internally by the HTTP and it is passed as a second parameter to the request event. Exactly. You say, hey, server response outgoing message, and this outgoing message stands now for streams, bro. From this particularly a way of handling it. A string is an abstract interface for working with stream data in node.js. The node streams model provide an API for implementation the string interface. There are many string objects provided by node.js. For instance, a request to an HTTP server, a process standard output, okay, are both string interface. Streams can be readable, writable, or both. All streams are instances of the event emitter, which is now this class here that is depend on that. It's the, hey, all event emitter emits the event new listener when the new listener are added and remove listener when the existing listener are removed. So this is now this particular class, right? It's like, hey, I'm going to now from this class, it's like, hey, this is the event emitter. Okay, that is extend from the event emitter. Then now I can have access to this. Exactly. So by creating is this, I say, hey, I create now this instance that I can have access to all of this property here, where is new listener and remove listener and emit. But again, it comes from this particular streams event. Again, this go beyond the scope of this, but the idea is that by creating is this. In fact, let me actually do this in Copen, right? Say Copen. Oh, Code Sandbox, my bad. Okay, I want to do this in Code Sandbox and say, hey, I want you to create a new repo with a basic node implementations. Here is now HTTP 1.1, all right, versus HTTP 2.0, right? Okay, let's get into this. Let's get it. Sorry. Let's get ready to rumble. That's right. You hear me right. Let's get it to. Okay. Here we are. That's right. Let's get into this. Okay. This is our index. We're going to see this actually running. It's actually hello called Sandbox, which is great. All right. Now it is time for us to actually use that. Okay, so you can see here we are now have access. Unfortunately, let's gonna make this thing here. Okay, so unfortunately, because this is now ES6. Sorry, it's CommonJS model definition. Let's see if we can actually use is our import. You know. Instead of doing this, I'm going to see if we actually can use the import and say, hey, I want to get this is from the HTTP model, And as a way to indicate that this is now an internal model, this is how you can separate it from internal models and user-defined models. All right. So after that, I want to actually see if this work. Right. So I save this definition and say, hey, I cannot use this import statement outside of a model. It's because warning to load ES model, set the type model in the package logs JSON. So now I want to now node recognize this and say, hey, in the, let me see this, please help me. Okay. So hey, this is type. Okay, I want you to be now model. All right. Another way to actually tell Node that this is now a model without breaking compatibility, all right, is that use the .mgs extensions for that. So you can say, hey, no, by the time you run this, if you see any of this file with this funny extension, ms, model JavaScript, I want you to please don't complain about it. Okay? But it say, hey, cannot find model project sandbox here. And it say, hey, project sandbox index. Okay. Exactly. Because we need to actually tell, hey, I want you to is inspect that in the package JSON. Because it says like, hey, I couldn't find any file with that. You know, if we now interesting. If we now rerun this, okay, you say, hey, open task, stop it, okay, and now start this, start the process. No, you're gonna start it. Now we can have access to this, right? Which is great, which is cool, awesome. This is exactly what we want. Absolutely, absolutely. So with this .mgs, we were able to use now this ES6 model, okay, without breaking backward compatibility. And then you need to migrate each one of those files in your programs slowly but progressively. Okay. That is a task in itself. So as you can see, hello Go Sandbox, and now we can have access to the HTTP. This is great, okay? Because here we can say, hey, I want you to know is using the ES6 model. Hey, please import is now the HTTP2. If I correct me if I'm right. Oh, I'm not sure if it's okay. HTTP2 from node internal model called HTTP2, right? All right. So far so good. We actually now have this two object here, and we can say is, hey, this is now HTTP 1.1, and this is now HTTP 2.0. Okay, good, awesome. You copy here, and then we're going to now actually use this. So by the time we save this, it's exposing this giant object. As you can see here, you have now the HTTP2. The HTTP1 is a connection listener. Here is a private method. You have all of the method that is actually now able to process ACL. This is interesting. You can also process this ACL, which is like okay, status code as well. Exactly, all of the status code that you can have access to, from 100 to 200, 300, 400, 500. 100 indicating is information status, 200 is successful status, 300 is client error, 400 is 300 is usually for yeah, 300 are for okay. 300 is for clients error manifesting. 400 are for network errors, and 500 is for server errors. Correct me if I'm wrong. In the exactly, so in the status HTTP code, it is safe to assume that 100 is for status, 200 successful, 300 client errors, 400 network errors, and 500 server errors, right? Not exactly. Okay, correct me. Oh, redirections. That makes sense. Yeah. Okay. That's exactly what I want to fill the gap here in my knowledge. It's like 300 is for redirections, 400 is for client errors and servers. Okay, that makes sense. Okay. Good. And as you can see, we got all of this property here. But now here, look at this. We actually now have a couple more properties here, like HTTP2 error frame size errors and season clients and stream state and flags and default settings and max and NGHTTP2 initial window size and strategies and all of these kind of properties, as well as the HTTP2 header status, method, authority, scheme, path, protocol. Interesting. You can have access to the header path. Okay, it's similar for the protocol, encoding. Okay. So you have now all of these headers already defined here. Jesus, very touchy guy. Similar for the cookie, day, e-tag. Oh, you have all of these headers data here. In an HTTP2 server. Oh my God. Holy French toast. Nigga. Oh crap. Interesting. Holy moly. Method. So you got all of this. Okay, you got is the HTTP2 additions, okay, which is in the method, as well as the headers that you can handle this. All right, I don't think anything like this, it has keep alive and all of this, but I don't think anything like catch and that kind of thing. Catch control. Interesting. There you got it. Catch control and authorization for that. Okay. And the HTTP status methods for that. That's quite interesting. Also, you have now the create server, create secure servers, and this kind of thing. The HTTP to server request and server response. That is made from this. It is a readable and extends from a stream. Okay, holy moly. Okay, that's quite interesting, bro. So you have the methods and the status code. So the way how they organize this, you have now also seen things like agent, client request, incoming message, outgoing message, server, Mm-hmm. You got validate headers, validate header value, get request, max header size, and global agents. Okay, this is something interesting. Okay, let's get into this, because now we are about to is what the French story. We're about is to create our first HTTP one server. Okay, so when we do that is by yeah, I just want to have the feeling of this. So I want you to is now write this and say, hey, let me actually here is write it down here. So you got now this cons HTTP. This is HTTP one. You're gonna actually call the method from HTTP by saying is the create server. All right. What are the things that this create server accept? Okay, it is the request listener. Okay, okay. So we might want this to now create is the this by saying this is now the request and the response, and by the time that happens, here we're passing is a callback here. So by the time that this request URL, I'm assuming that you got that URL right. Request URL is equal to this, all right? Is equal to that. I want you to now start to respond to that. And this is when we're starting to now defining is all of the use case that this server is gonna handle that. So as a way to identify here, we're gonna say, hey, this is now the HTTP 1.1 server. Okay, makes a lot of sense. You say HTTP like this, HTTP 1.1 server, request receive for, there you got it. So request receive for the request.url, right? And here is when we're starting to define all of our use cases, and when now frameworks like Express actually makes our life much more simple to manage around and scale. That's one of the reasons why actually we're looking at HTTP 1, HTTP 2, because it's about scalability. The more we use a particular tool, the more we need to this to scale. All right. So here is the switch case. So see what? Here is this switch case. Okay, so this is the switch case that this was code generated not only by Claude and say, hey, instead of having all of this if, so based on the request.url, I want to handle now is this particular case. Hey, this is now the path. Okay, I want you to now send a response to that, which is, hey, I want you to now do something like this. It's going to now respond. Response right here on the buffer. Right head, interesting. Right head, 200. All right. With this particular data, with okay, on the header, you're gonna say, hey, this is now content type. This is the header. Interesting. You say content type. So content type of the JSON, right? Or we are sending is HTML. Okay. You say text. Content type is text HTML, right? You say text HTML. Okay, and not only that, is after that you're gonna say, hey, respond on the response. Is a right head, right head here in Node. Okay, but we are now writing is the head. Simple writing. We're writing is the head. We are writing is the head here. What is this? It's like right head, like that. Exactly. It's like right head. Hey, we received this, and this is now the proper metadata that we're gonna send. And then we got to now is to actually send that data or to write that on the buffer. Okay. What it means in this case, you say, hey, you can say is n response.n, something that they're doing here. On this response, the n, which is now, we'll take a look at the n, dot n, response.n, and the body. Okay. So this is now when you're going to send the data, the encoding, as well as the callback. All right, this message signal to the server to allow this, right? If that is specified, it is similar in the effect of calling the response.write, that encoding, followed by the response.end, which is the callback. If the callback is specified, it will be called when the response stream is finished. Okay, quite interesting. Quite interesting. Quite interesting. It will be called. It will be called when that is sent. As an array like, okay, and then the callback. So as a way to test this, you say, yeah, this is our entire stream here. You say, hey, you got it. Basic HTML here. Just gonna make this here, like so. So we can actually send is the structure that what we are sending here, right? Similar to this as well as this. And then we are sending is an image that I don't know where in the F are you loading that image, similar to a script. I don't know where you are actually gonna load that. And there you got it, right? This is what we're gonna send, right? Wait, what? And we can also specify it's a callback here, all right, to trigger once we already send that. Useful as a way to actually is now keep track of how many requests we are sending per second. Okay, so oh, this is the HTTP server. Exactly. HTTP 1 server, because otherwise it's going to complain about it. Okay, HTTP 1 server, right? So by the time you are doing this, okay. So yeah, we're handling is this just particularly case. There is also the image.gps, where we're gonna send now this simulated image data, similar to the script as well, or it is writing that. Oh, simulated image loading and simulated script loading, okay. And if it's not, then you say, hey, it was not found. Okay, all right, good, good. So this piece of code, which is very, very interesting here, is this one, because we have already one. All right. So by the time we now is called to this, let me see if we can actually open up a new browser here. Can we open a new browser here? Can we open a browser here?
Can we open a browser here? Again, we haven't run this, so we need to start to listen to this. So what we're going to do is this. Stream.response here. So this is now the port that we're using. This is now when we're going to start our server. In our particular case, the way how we start our server is by indicating is the number of the port. HTTP one server listened to this one, right? And then you got it. However, if we want to, because now it's say this one, it's like say, hey, request receive 4, and then you throw a server, say, hey, error, send header to write. That's interesting. Write head. Cannot write headers after they are sent to the client. Server running on this port. Request receive for this. And then he are now handling is this. Oh, I think no, we're handling that properly. So by the time this receives this, it say, hey, I gonna crash this, okay? Because I cannot write. Write head and response.end. HTTP headers sends cannot write headers after they're sent to the client. Oh, are you doing that? One of the main issues here is that it's right. It's end. Perhaps it's because they are not using this. This is not the way how you can do that. Exactly. So HTTP it's because we're sending is that twice. HTTP 1.1. It's because we're sending is twice. But the problem is that how you are actually is generating that. Wait, what? No. Chill. But it's like a response status, and then you send that as a JSON. But no, you are using is okay. Again, from the HTTP 1.1 versus HTTP 2.0, the HTTP 1.1 is throwing new error here, but this is because we are somehow is now writing this afterwards. So we need to actually silly me. Oh, that's why you cannot use is a okay, that makes a lot of sense. Okay, that makes a lot of sense. It's because for some reason when we are writing here, it's like we're sending is this twice. No, we're not. No, I don't want. No, I don't want. In fact, I want to write the head properly, okay? But then I want to now is return this. Okay, then I want is to return this. Interesting. Okay, and now it's working. You say, hey, receive this request. Okay, and then now it sends that properly. It makes sense. It makes sense. It makes sense. Okay, okay, because he assumed that. Similar is for this. Say, hey, time is this return. Similar for another return. And similar for the another return here for that. Okie dokie. I don't have any way to actually test this. I just wanted to see if we have now some sort of browser like. And how can I use, or how can I open a browser tab in Sandbox from a node.js environment? What the French told you do? Okay. In Code Sandbox website. Oh my God. There you got it. Jesus. But this is documentation. VM usage, project usage, run setup. Oh man. I'm gonna run this locally here. Save myself time, that kind of thing. Period. Take care. Bye bye. Which is now is creating this say index.js. All right. This won't work because this is now on model. Jackie, all right, there you got it. Now I want you to just run the index.mgs. It's a no. Really? Oh, because it's here. Now do this. There you got it. So by the time now I go through this server and say, hey, local, I navigate through that, I send this request to the server and say, hey, there you got it. Of course, the image is broken, blah, blah, blah. But we are actually receiving is this data from the server, right? From the server. So this is quite interesting. And we're receiving is this HTML 101 page. So far, so good. The other is now, when we need to implement is the HTTP2 server. Now things are quite different because we say, hey, let me actually create a secure server here. So by default, encryption is necessary. Question, is this actually really necessary? No. And HTTP2. Determine if Crystal supported is unavailable. Server-side example. Now you create a secure server, my friend, for that. So now you create a secure server from that. So you can say, hey, let me actually instead of actually getting it from the HTTP2 like that, we say, hey, create secure server. And this is now create server. So you can abstract this by saying this one, and then let's go to create now the secure server, okay, which is const HTTP2 server, right? You say create secure server, where it receives now is the request handler. So we can pass this a callback here. It seems like so, which is on request handler, where this is now exactly a callback. Okay, a callback for doing that. But in this case, instead of actually doing that, let me see how it's actually generated here. It's saying, hey, once I create a secure key for that, let me now on that instance start to listen to. Okay, as a way to decouple is the configurations from, that makes a lot of sense. The configuration, the configurations from the, the configurations from the implementation. That's something powerful. Okay, which is something that you need by default. All right, here this is the option that we're gonna pass here. Okay, and here you say, hey, they're gonna receive the key and the certificate, which is something that is needed, especially as a way to establish this HTTPS connection. It's like, hey, I need you to find this read file sync. Okay, initially read file sync from this model. Okay, and this is what I want to actually do. This path, do we import that? Path dot join, and then I'm going to now pass is their name. Well, this is something that is from CommonJS. All right. Provide an example. Provide an example. Provide an EX6 ES6 example to implement it. Exactly. It's like, but you have now this. This is service configuration, right? Oh well, you went crazy. Interesting. Both of them extend from the base server. Okay. And then you have now the handle request here. Similar for here, HTTP2 server, extend base server as expected. Create server, async handle string. All right. So this is the this.config http2 port and config this dot slash config to SSL config. You are not defining this type of that, which is one of the things that I hate from you. A web performance tester, and there you go. You put also the performance tester. What is the performance tester? Is this base class? Okay. Make HTTP1 requests. Make HTTP2 requests. Okay, but this is why interesting because on this server you pass now these configurations to this. This is SSL config that it needs to create this. You're gonna pass this the port, and this is a config. So by the time you create this, which is app star, okay. So by the time you create now these applications here, you say, hey, let's go to now is run this, okay. Let me actually create this 2 instance of my application where in one version you're gonna write is the HTTP1 server and the other is HTTP2 server. Okay, one of them is both of them we're gonna have the port, but the last one we're gonna have now is this configuration, which is funny because it's this configurations that start them. So with promise you're saying, hey, I don't want when this happens, but I want to know by the time that happens, I want to get the value of this, which is the star from HTTP1 to HTTP2 server, which is the star, which is the star, create server, handle stream, which is the star here. It say, hey, let me access to this dot server and listen to that. Exactly. The new promise resolved is the server listen to this port, and by the time that it's done, okay, I want you to now is notify this as a promise to say, hey, this is already done. This service is already executing. So by the time now the star actually is being called, which is gonna receive, it's gonna return as a promise. I want you to now have the completion of that. All right. I want to have all of them, these 2 servers running, and then perform the test here as expected. This is quite wild code, bro. This is a quite wild code. Yeah, I don't intend to do this. Just want to see for the sake of the example that actually sees work as expected. It also throws a particular error because exactly it couldn't find any of these things known as the local private key here and that kind of thing, because it's something that it needs to load that. The question is, Oh, exactly. You got it. You got it, right? The question is more for this dir name. Exactly, it's because it doesn't recognize that. Dir name is not defined in an ES model scope. That's right. So dir name is not recognized in a ES6 model. What is the alternative to read a file in node.js? Dir name and join. Why you overcomplicating this kind of thing, bro? You just go away. You just lose, bro. You just lose. So you actually are creating all of this handle and this abstraction, that kind of thing. Is like, man, keep it simple, bro. Keep it goddamn simple. File to pass, which is import meta.url. Exactly. This is the recommended way of how you can get access to that. Import.meta.url, which is import.meta.url for that. Okay. But this is because we wanted to actually read this particular file. File we have not been. File we don't have then. File that we don't have, and that we need to generate is this one. Oh, that makes sense. That makes a lot of sense. Okay. No, I don't want to open the preview, bro. I want to open is the exactly to to generate the keys for the HTTP 2.0 server. Let's get to do this. This is the code here. This is now bash, right? You will need to install is open SSL. So open SSL. I don't think that I have that thing. We believe everyone should have access to security and privacy tools, whoever they are, whenever they are, or whatever their personal beliefs are, as a fundamental human right. And here we are. Library mission. Yeah, but exactly. And let's now, because I don't have that installed, what I can do is to generate them locally and then now runs it. There you got it. You got these two files, right? Just for demo purpose, I'm gonna paste this, but this particular file is something that you should generate them. Okay. Why not? Why why not? Interesting. It doesn't allow me to throw anything of this. So can you now help me to generate then that? There you got it. All right. That's great. That's cool. Because now, by the time we want to have access to these files, is at this position. All right. I want you to now give me if the files here, which is by concatenating that as a string. So you got now this simple example here. All right, I want you to now read that and, well, have access to that particular file. This is something like this. Or because we're using is now join, okay, we can say, hey, let's go to now is append that in a secure way. So this is the HTTP, where the F is this, there you got it, path the join, that's right, which is in our case we say, hey, is this one, right, is this one, is whether is the key, the private key, okay, whether it's a private key that is auto-generated here, which is thanks to the OpenSSL, okay, and the other now is the certificate. That is something that is used to actually see if we are now actually getting to the proper server with the right certificate. Hey, is this the certificate of this server? Good. Which is something that we're going to exchange here. It's like a import.meta.url, okay, and the now name of the certificates, right? So thanks for the OpenSSL to actually allow us to do this, right? And I think there was a lot of battle behind the scenes, a lot, like a lot. Legal battle mainly. So yeah. All right. So that's good. That's great. Okay. We can now say npm star. Say, hey, there is no executable here. Okay. Where am I, by the way? Exactly. So npm. Oh, I need to. Sorry, it's node. My bad. Node start. Of course, it's throw an error, but we are actually running is this one. You say, hey, cannot find project workspace start. Jesus, is npnx run? It doesn't. Is start doesn't work? Really? Run star. No. Why not? npm star. Okay, now it's working. It say, hey, but this no such files or directory here because it's exactly it's not here. It's important meta URL. Oh, okay. It's because he's thinking that okay. Okay. Mm-hmm. Their name. Okay. Their name. Now this is supposed to work. The path argument must be a type of string, receive undefined. Really? The path argument must be a type string, receive undefined. Okay, so it's like, so file name. So file name, no, because file name is now this particular name here, and then we got is the URL, bro. But this is quite interesting, a very interesting scenario. Okay. Proper, yeah, how can I access to the proper file, to the proper directory from the following example, which is this one. File URL to path. Exactly, join serve path, which is, where do you find that? You fucking love to overcomplicate this kind of s, bro. Their name file URL to path. Oh, this is very specific. This is very specific. It's like file URL to path. Oh, file URL to path. Oh, and then say file URL to path. Receive function file URL to path. Oh, file URL to path, which is import.meta.url. Okay, so they're supposed to return is a string, am I right? Exactly, they're supposed to return is a string, right? So does not. Not a directory. Open here. Okay. Okay. Their name, the file name, which is file URL to path. Okay. Just these things overcomplicate things unnecessary. So from path, okay, from path you can say, hey, give me is now the dir name, directory name. Jesus. Okay. Give me now the directory name here and stop playing games with me. And stop playing games for me, right? Stop playing games for me. Path. And it now says does not so the request model does not provide an export name path. For real? Oh, do your name? I mean, it's join. My bad. It's join. Join. Exactly. Okay. So don't use the path. Only uses that particular instance as a way to get access to that, and that'll work as expected. But you say, hey, the path argument must be a string. Receive function dir name. That's right, because this is it. Dir function is oh, here we go. I think it's gonna fail as well. No, I think it's gonna fail because it doesn't have a dir name exactly. Because here is the import.meta.url. Again, very non-specific of how the things actually works. You know, very non-specific of how the things work. But as you can see, it's actually getting that properly. But you say, hey, no such file or directory open here. Workspace, localhost private perm key. Also, just follow the directory here in workspace. Localhost brave key here. Perhaps because you don't allow me to access to this. Well, it doesn't mind. Let me actually run this locally here without any issue here. There you got it. That's right. You say no, please. Index.mgs. There you got it, right? I don't know which version of you are copying here. Yeah, that's right. And here, by the time we wanted to actually listen to this port, which is you're gonna use is now HTTP on streams here. And this section here is quite interesting. No, I don't want it. Yeah, you generate a lot of garbage, bro. You generate a lot of garbage, but a lot garbage. It is, it's astonished the amount of garbage that you generate. Like it's like of irrelevant things. HTTP2 server on string headers, console log, and then you got it. However, it say is this one is that hey, this file doesn't exist. I don't know what to do with this. Let me see if by running locally here I can actually do what it's supposed to. Come on, don't be like that. And then I want this to actually is now listen to that server. Okay, makes sense. Okay, and let's get into this. It's a hey, HTTP2 server is not defined because HTTP2 server, HTTP1, HTTP2. What do you think you are doing? That's a very interesting question. Okay, because it's this. All right. Now you're listening to this particular report. It's a HTTP2 server is not defined. Hey, please. Hey, come on. Stop doing that. Is there any reason you don't want to copy here, man? Just okay. Please don't. I don't know what you're doing, but please don't. Okay. Good, right? Are we cool? So I want now to run is this server here. Okay. Of course that won't work, but the whole point of this is to see it's a localhost cert and private key is here, and say hey, I cannot actually detect that. That's quite interesting. But the file exists. I'm getting is this, but it's some sort of end of end. Let me ask ChatGPT for that. I am getting this error despite the files are created. But this is because some read entry, no error entry. I think it's for the permissions. Make sure the user running node.js process has permissions to read the file. Yep. I think it's for permissions. It's like, hey, you don't have the permissions to read the file. That's why you say, hey, no, that doesn't exist. In this case, you can do something like this. It's like, hey, please give now the right okay, chain mode here, C mode, that'll be is 644, right? of the local. That's right. Similar for this another file, but in this case is the cert. That's right. And now by the time I want to run this, you should be able to read that, but it say, hey, that doesn't exist, especially in the workspace. But they are, you know. File project workspace, localhost private key depend. But the file exists. Oh, crap. Okay. You got these particular files. You're supposed to read them. Here, I already changed that permissions. And you say, hey, you know what? No. French toast, what you doing? The French toast, what you doing? Okay. This is now the start. Okay. And it tells me that, hey, no, I cannot read that file. That file does not exist. I changed that change mode of the local. Okay, change mode of this particular file here, local. It doesn't exist because it's local. It's local host. Oh, I mean it's 644 to the local host cert. Okay, I'm not sure if they actually changed that. Let me run this. I'm not sure if I even am able actually to run sudo commands. I am. That's scary. Yeah, and then cert as well, and the key as well. Private key as well, right? It means that now if I do is source dot bash because it's source, because it's the root, for real, Jesus. Okay. Anyway, but I'm assuming that you're supposed to actually do that. So change that, so I can now run it and say, hey, is npm star, and still say, hey, I cannot find that particular file. That's very interesting. And the funny thing is that you can have access to that. You definitely can have access to that. But here you're telling me that you can read that. Open sync, right? You say that, hey, I cannot read this. No such file or directory. Open file here. But they exist. This is called open. Okay. Okay. That's well, in any case, let me see if you are right, right? Let me see if you are right by saying it's this. It's like, hey, we're gonna see if you're right, right? Come on. Similar for this. We're gonna see if you're right. This well. Similar to this, right? So you say, hey, now run this. The property local private key pair is invalid encoded, receive encoded. Okay. Okay, that's another error here. That is okay. Then we need to actually indicate that what is the encoding here. Okay. Which is the UTF-8 in this particular chart code. You know, that's one of the reasons why this piece of code actually don't generate is proper valuable data. You know what it means? Like, so by the time that we want us to read this code here, I mean it's this one. I mean it's this one. My bad. Okay, I mean it's this one. Exactly. It's because the second argument is expected to receive that. It's like, okay, now it's running as expected. Okay. We have to kind of hard coded that. Doesn't matter. As long as it works, great. It'll work for me. Okay. So now that this is running, but this is interesting because how the way it's running. Okay. This is very, very interesting on how this is running. So you can have now the HTTP 1.1.js file or the IMGS, okay, and here put that particular code there. So you can say, hey, I want you to now export this seconds. Of course, and you're gonna need is to create this server here. Okay, so now you can have access to that. And the other is the HTTP2 server, which is this. All right. Where you say now, hey, let's go to use the HTTP2 0.mgs, All right, as a way to now run these servers, but in this secure context, right? Not only that, but we need to also is read this file. All right, let's get into this, shall we? Let's get into this. I'm going to export this as accounts. There you go. All right, so by the time that we can have access to this, all right, and import them here as HTTP server by saying is, hey, I want to now to import from the HTTP 1 dash here dot mgs. I'm assuming that I have to put this here and say, hey, this will be the HTTP 1 server instance. Pretty much is the same for the next one, which is this. It's a HTTP now 2 server from this to 0 here, and this is the name of a port, and this is something that is supposed to work as expected. It say, hey, no, I couldn't find this, cannot find a package like this, so I'm assuming that there is no need to actually pass is the package like that. It say, hey, I couldn't find any HTTP 1.1 model. Okay, model, that's right, because here is what we are exporting here. Exactly. Yeah, it makes sense. This is what we are exporting here. We are exporting is in fact, we are exporting is the HTTP 1 server. That's what we're exporting. Similar for this is the HTTP 2 server. Right? So once we evaluate this and say, hey, cannot find package here, importing here, what about is .mgs, right? It say no, I couldn't find that. We say export cons HTTP server. Let's say now say export this, okay, but for some reason it say no, I cannot find that. Error not found, cannot find HTTP 1 or this. It's important from project work their index here. It say I couldn't find this. Is there any reason for you don't find this anyway? Okay, is there a particular way of how you can find this? Can you tell us why you couldn't find that? Cannot find HTTP method from this. I'm assuming that is okay. My folder structure. Oh, way before you're starting to hallucinate, bro. Way before you're starting to hallucinate, bro. I want to modularize HTTP1 server and HTTP2 server into their own files and import them in the index.js. Oh man, you're gonna, okay. Export classes as servers, that's right. But by the time you want to import that, Jesus, you hallucinate vastly, bro. Exactly, but okay. It's this one. It's because of this. Is this particularly okay? Is the file structure, and that we need to also indicate that this is an MGS, right? Exactly. Similar for this. Okay. Makes sense. Makes sense. So now this actually worked as expected. So far so good. So you can see it's open preview here and open preview here, right? Both of them are opening is preview. In the case of HTTPS, it's actually responding here as it is, but the HTTP2 is actually not responding. So this looks like the dev server has not been started yet, but we already did. We already did. Oh my god. Chill, bro. Exactly. The HTTP2 server we're trying to access to this is not responding, which is quite interesting. This actually works as expected, but this another one is not as it is. Okay. Okay. Even though that we already exactly. Even though that we are now creating as HTTP server 2 as expected, all right. But for some reason it's not actually listening to. The HTTP2 server now is running in this port, okay. Port 3001, okay, but it's not able to handle or to receive those connections. Again, both of them were running, but the time you're using is this switch case in here, you are not is responding as expected. Okay. 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 Exactly. Stream respond and stream end here. Send the main HTML file to this. Question: don't we need this to actually return that? Okay. I think it's because we need to return something here. I think we need to return something here. But it seems we're not. The stream is a duplex. Okay, allowing these two communication. So on string, you're gonna do this, and on error, you're gonna do this. So on string, you're gonna now be able to capture is the string and the header, and responding accordingly. So on the headers, if the path is now this, but that's quite interesting here, because this is particularly noisy logic that is generated to. String.response is this. And on the client side this is the logic here. It's like, hey, I want you to connect from the HTTP to from this. And I want to send chunk of data in this kind of thing. But it seems that it's not working, but it's mainly because this piece of code here. You know, it's mainly with this piece of code here. Exactly. Service is on response. It seems the server is the server never responds based on the following code. Could you identify what is the problem here? I'm assuming that is somehow you are reading is these headers, bro. I'm assuming is that how you are reading is this header, bro. I'm assuming is how you are reading is this header, bro. I'm assuming it's the way how you are reading is this server, bro. String response and string end. If you take a look at this is a string response and a string end. So based on this simple example, it's a string response and string end, but it's on the string. String response and string end. And then you say server push, proactively send resource we know the client will need. So we don't need to actually send anything else? Really? Because this is only on this. Let me actually now attach is the on error to actually know what went wrong. Okay, and then do this, right? Okay, cool. So HTTP1, it actually works as expected. By the time we go to this, right? By the time we go to this, it's like So let's go to do something pretty straightforward. It's like, hey, I don't want you to do this. All right. You just only want to run is the pour that, right? You and it say this. It's like, even though that I'm running is this, it's like I'm getting into this, but I never triggering is this. Okay, that's very interesting. In how you're actually handling is this, right? It's like, okay, we're gonna make things simple here, right? I'm gonna do this. You, in theory, supposed to actually is send some data. Let me actually put a simple example here. It's like, why in the F is this things are doing this? This is an error. Alright, I already created secure context. And on a stream, I just only wants to do is this. Okay, hey, please, it's going to only send is this. Alright, same with this. Can you do this? No, you're not. Okay. That's pretty wild, bro. That's pretty wild, bro. Server HTTP2 is running, but it's not responding. Server HTTP2 is client-side example. There might be some things. There might be something here going on. Okay. In response, end with this. Oh my God. Why is this not able to handle this? Not even the base case. That's quite interesting. It's not able to even handle this use case. My question is, are we calling that localhost? Is it unable to connect? Perhaps there is some running thing stuff going on here that is using is that particular port, but it's supposed to actually reply with something at least. Let me do this. All right. Open preview. And he's like, So npm run star. Okay. Oh, for real? Will not determine executable to run npm star. Finally, you throw me an error. It's like, hey, this port is already in use. So now we're talking. So now we are talking, my friend. Let me actually put this French toast port some other places. Oh, really? So all of these addresses will be used? Oh my God, here we go. It's gonna use this port to see. Oh my God, the connection is blocked. That's all. Server error listening in addressing use already in use here. You know what? It's gonna do something much more straightforward. I wanna do this here. No. You has caused a lot of trauma, a lot of problems, unnecessary problems. Get the French toast out of here. get the French toast out of here. Jesus. Get the French toast out of here, man. Similar for this. Get the French toast out of my head and my. Okay, HTTP 1. Jesus, you want to be very annoying? Alright, doesn't matter. Doesn't matter. We're going to actually hard code this, especially on here, because it's here that I want to take a look at this. All right. Take me to there. Oh my god, but stop, man. Stop, bro. No? For real? Now it's running. Okay. So by the time we access through that, okay, it's supposed to actually show us something, which is a local port. That funny port. No, in fact, let me actually make a more friendly port here. This one. Port 3000. That's right. And it said the connection was reset. Why the connection was reset? What about here? What about using this funny port? Okay. The connection was reset. The connection. The connection was reset. So I'm trying to get into this port. Okay. But the HTTP2 is quite interesting on how that it works. It's like, what? I'm actually cloning this, and even though you're not going to do that, am I doing content type char UTF-8 with stream HTTP2 server? All right, with this particular certificates, the private and the public here. And you don't want to actually is what about for Chrome? Localhost didn't say any data. Okay, so localhost in HTTP2 is not sending any data. What happened? It's like, what happened? For real? Allow HTTP 1 true. Enable fallback to HTTP 1. So this is on error, on season. Okay, on error and on season. So by the time that I define here and attach them here, which is on error and arrow seasoning to this funny port, the connection was reset, but it means that it is never get out of it. It's like you're never even being set, bro. That's wild, you know, because by the time I'm doing this, I change this to this, and then I uncomment this. Okay, and I comment this out, and enough. It's quite fucking annoying, bro. Comment, bro. Comment. Yeah, Jesus, and it's not recognizing what I'm telling here. No, bro. Okay. I don't. Oh. Stop. No. Oh my God. You're gonna. You close it, right? Why you so complaining, bro? No. My fucking God. Jesus. Why do I need to handle this? Oh my God. Now our port is running at the proper port, and now this is working, but the HTTP2 service is not working, and that's to me is quite puzzling of all of this. Anyway, make it simple, make it deadly simple, bro. Make it deadly simple, bro. Make it deadly simple. 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 No, Jesus. Why? Okay. Exactly. Is this one? Jesus. Jesus. Okay, command alt shift. This you got. So by the time that I'm doing is this, okay, and then I add, and then I do this 3000. Of course, that doesn't work, but this actually work. That's to me quite interesting. That's the pretty fucked up things of all of this. Is that this is not even working, my friend. This is not even working, bro. This is not even working, bro. This is not even working. So generate a basic working example of an HTTP 2.0 server in node.js. Why you don't want to create this? That's the puzzling thing, and why this doesn't actually work as expected, my friend. Because by the time no. Okay, Claw, you hallucinate a lot. Claw, you hallucinate. By say a base. Oh my God! No. Well, let's go to start a new conversation. You started hallucinating. Jesus. Generate a basic working example on an HTTP 2 server in Node. Basic, bro. Basic. Stick to that, bro. Stick to that. Basic, mother. So it's supposed to work. In theory, this is supposed to work. In theory, this is supposed to work. Wow, why this is quite puzzling, bro. So by the time I'm reading is the streams here, okay, in this server, it's like I'm not able to. Let me close this. So if I do this, okay, stop leaving me blind, bitch. Jesus. So by the time I doing this, okay, and then I say, let's go to run this particular server http2.js with this particular code, and then I say node of the http2.js. You say, of course, this things called server key does not exist. Let me actually in fact pass now is the key that you need to, okay, so you can actually work in this particular environment by using is now this credentials. Okay. Good. This is now the keys. Okay. Now this is the certificates, and the other is the private key, which is this. Okay. And we can go back to the code and doing this. Alright, so by the time we run this, you will actually run as expected. So if I go here and then I navigate to this, it's like, hey, yes, warning, potential security risk, but I want to go on. Accept the reason, continue. This is not working, and I don't know why it's actually taking you so many problems. Create secure, okay. Read files, create secure here. There's some messy. There's There is some messy things here that we are not able to see here. Because by the time we export this, okay, that was quite annoying, by the way, too much annoying. Way too much annoying, bro. Way too much annoying. It's like unnecessary annoying. So by the time we're actually reading this, okay, and by the time we say this, and by the time we say this, and we just only supplant this with this, and then I will try to run is the both servers here. Now it is working as expected. Okay. That French toast was that, bro? Anyway, now it's working as expected. So get the path from the headers and then handle different routes here. Very, very interesting. You can delete this. Okay. And you can I think it's the break statement here that was lag off, but in any case. But now is this hello HTTP to server. And as you can see, we're actually set a request header. It was a get. We can actually see more of this data, as well as the sec, DNT, and priority. So okay, all of this was just to create is these two basic example of this, right? Secure failed data, what? Exactly. We can secure this insecurely and securely, right? Both of them. Both of these two work. Okay. So we can cut this, stop this, going a little bit back here, going to the enterprise, going to the front-end system design, or system design front-end. That's right. Okay, because we might want to modify this by saying is HTTP or HTTP version server. Okay, make dir of this HTTP version server. This is when we're going to define inside of this all of this folder here. I want you to open it with code to just simple copy and paste them, right? Paste all of these folders here. That's right. Like you do that. So we can actually check here. That's right. We can delete this. Also generate some sort of package JSON or not. It's independent. It's also something that is not required, by the way. But we need to actually define is the private key and that kind of thing, so on and so forth. Okay, I know what is the name of this game. There you got it. Perfect. Now you delete this, right? And all the thing that you need to do here is just is run this with that, run the index.mjs, and there you got it. So you're gonna have now a server running here in an insecure way, and then a server running here in a secure way for that. That's pretty much. So if you're trying to access to this, it say, okay, connection was reset. That's one of my problem here is because by default you need to connect to this in a secure way. So things started to okay, it makes a lot of sense. Okay, it makes a lot of sense. So on the readme, we can open our here and say, hey, let's go to actually is now create is this readme. Okay, .mdm. Okay, is a HTTP 1.1 versus HTTP 2.0. Okay, a test in Node to create an HTTP server. It's a test in node.js to create an HTTP server. A test in node.js to create to know how to create an HTTP server in 1.1 and 2.0 versions. Okay, so what are the trade-off here? Very, very, very important. Very, very, very important. Because here you're starting to hallucinate a lot. This is something that is not good. This generated code, what it does is to actually give you a lot of noise, unnecessary noise. Unnecessary noise. Unnecessary noise. Unnecessary noise. But unnecessary noise. So multiplexing is one of them. So server push. Okay. And the other is header handling. It's also important to see what it's doing behind the scenes. Web. And connection handling here. And there you go. So to run this code, you will need to generate certificates. That's right. In our case, we already got them. Okay, npm init, which is a way to say, hey, generate is the necessary package JSON for this. All right, and then you say, hey, npm just and then you can say is now do an npm or npmx star, right? There's an npm star. It's gonna run this. Missing script? No. Interesting. npm star. Here it's going to define this star as the node index.mgs. So now by the time we can run this node, chill, 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 chill. By the time we are here, okay, you can say npm star, and that's work. Exactly. And then you say now npm star exactly. So by the time we're looking here is this one, you say hey multiplexing server push header handling, sends header as a plain text, use a special path header and compress header frames, connection handling, use new connections for each request, use a single connection with multiple streams. And then you got is this. You will need to install node.js. Exactly. So there you freaking are. Okay. Holy moly. All right. There you got it. That's very interesting. And that'll be all for this video. Take care. Bye bye.